Hello students, we are going to study what is the meaning of formal charge and how do we calculate the formal charge. Now, it is a charge assigned to an atom in a molecule. Now, if the molecule is ozone, you can see I have written oxygen, oxygen, oxygen atom. Okay, and there are some charges written. Plus charge is there, minus charge is there, zero charge is there. So, we are going to study how we came to know this plus charge came, how we came to know minus charge, and how we came to know zero is there. Okay, so this is the formula to calculate the formal charge. Number of valence electrons minus number of dots minus number of lines. This is a simple formula which I have written. Now let us focus on first oxygen atom. First oxygen atom, we will calculate number of valence electrons. Okay, now number of valence electrons in case of oxygen is 6. Okay, we all know oxygen is having atomic number 8 and electronic configuration is 1s2, 2s2, 2p4. So valence shell is this. So 6 electrons are valence electrons. Okay, I write here 6. Then minus is written, I write here minus. Now number of dots. Now what do you mean by number of dots? See here, we have 1, 2. Okay, so I will write here 2 minus number of lines. So 1, 2, 3. So I have number of lines 3. So this is equal to 6 minus 5, that is plus 1. Can you make out, students? Here it is plus 1, here it is plus 1. Okay, now let us go to the second oxygen atom. We are having this oxygen atom labeled as second oxygen atom. Now in case of second oxygen atom, number of valence electrons. See, number of valence electrons for oxygen is always 6. Okay, number of dots. Now number of dots are 2 plus 2, 4. Okay, minus number of lines 1 and 2. Now, so 6 minus 6 is 0. And yes, we can see there is no charge on this particular oxygen atom. Third oxygen atom, let us calculate the formal charge. Number of valence electron, yes, it is 6 minus number of dots. So 2, 4, 6. Okay, minus number of lines. Line is only 1. So your answer is minus 1, and yes, we can see minus 1 is there. Now students, you might be thinking from where we got this number of dots and from where we got the number of lines. So let me explain this now. Suppose I write the structure, Lewis structure of ozone like this: oxygen, oxygen, oxygen. It is a skeleton form of ozone molecule. Now I put the valence electrons. We have 6 valence electrons. So 1, 2, 3, 4, 5, 6. Okay. Now, so this oxygen, second oxygen, already I have explained, 6 dots are there. Now what happens is, you should first draw single line. Okay, single line should be drawn with the middle oxygen atom. Now for this oxygen, if you see 2, 4, 5, 6 and 7, 8, octet is complete. Okay, so this is complete. Now let us focus on this oxygen atom. So for this oxygen atom, first oxygen atom, we have 1, 2, 3 and 4. Okay, 3 and 4. So now 5 and 6. So this oxygen atom also valence electrons I have written. Now let us focus on this oxygen atom, third. So this particular oxygen atom, 6 valence electrons are there. 1, 2, 3, 4, 5, 6. Now students, if I write this structure like this, in this form, you will notice that second oxygen atom is stable. 2, 4, 5, 6, 7, 8. In fact, the third oxygen atom is also stable. 1, 2, 3, 4, 5, 6, 7, 8. Okay, but first oxygen atom is only having 1, 2, 3, 4, 5, 6 valence electrons. It needs to have 8 electrons in total. So what happens is, this is the reason that one of the electron pair from here, it shifts in between. Okay, so what we get now is oxygen, oxygen, oxygen. So single bond was already there, single bond was already there. Now this will be double bond. Okay, and hence now 1, 2, 3, 4. 1, 2, 3, 4. Okay, so this is second oxygen atom. Okay, now Look at the first oxygen atom. 1, 2. I write here 1, 2, 3, 4, 5, 6, 7, 8. So now this is also stable. Okay, this is also stable. And here third oxygen atom is this. 1, 2, 3, 4, 5, 6. Its own valence electrons, 6 valence electrons, and 2 from here. Okay, so this is actually the Lewis structure. This is called as Lewis dot structure of ozone molecule. So what we have learned in this video, we have learned how to draw the Lewis structure of ozone molecule and how do we calculate the formal charge assigned to an atom in a molecule. Now students, there are certain rules to draw the Lewis dot structures. Now rule number 1, count all the valence electrons. Okay, rule number 1, count all the valence electrons. So we are going to use this first rule for the next example, which is this. Tips to draw Lewis structure for NO3. NO3, what is the name of this anion? It is nitrate ion. Okay, so what is the first rule? Count all the valence electron. So I write over here, I am going to count all the valence electron. Now see, this is nitrogen, atomic number is 7. Oxygen atomic number is 8. So I calculate first the valence electrons of all atoms. Okay, so for nitrogen it is 1s2, 2s2, 2p3. So valence electrons are 5. Okay, 2 plus 3, 5 plus. Now for oxygen, electronic configuration is 1s2, 2s2, 2p4, and the valence electrons are 2, 4, 6. But students, just see, there are 3 oxygen atoms. Okay, so I'll write 3 multiplied by 2 plus 4, 6, this. Now see, there is one negative charge also. So we mention this negative charge over here, and now we write 5 plus 18 plus 1, that is 6, and 18 is 24 valence electrons. Okay, so in the nitrate ion there are total 24 valence electrons. Now just look at the second rule. Second rule says that draw least electronegative atom at the center. Least electronegative atom at the center, and other atoms you will write around it. Now in this case we have 2 atoms. So second step, we have 2 atoms, nitrogen and oxygen. Students, nitrogen is least electronegative and oxygen is more electronegative. Now I wrote this much, and then the third rule says that draw single lines or single bonds towards central atom. Okay, draw single bonds towards central atom. So now I draw the single bonds. Now fourth rule says that, okay, so second was least electronegative atom in the center, more electronegative atom towards the corners. Third, I have drawn lines also, and the fourth rule says that, just read this, complete the octet with remaining electrons for the other atoms first. So what we have to do is, we have to first complete the octet of these side atoms. Okay, let us complete the octet of the side atoms. 1, 2, 3, 4, 5, 6. Okay, and here 7, 8. Please remember, we have total 24 electrons to be allotted in this molecule. So 6 and 7, 8. Here 1, 2, 3, 4, 5, 6, 7, 8. Now both the oxygen octet is complete. But what has happened in case of nitrogen? Yes, there are 3 oxygen atoms. So we will mention 1 oxygen atom here also. Okay, so 1, 2, 3, 4, 5, 6, and like this 7, 8. So this oxygen have achieved octet, this oxygen have achieved octet, this oxygen also has achieved octet. But what about nitrogen atom? It is having 1, 2, 3, 4, 5, 6 electrons around it. So what happens is now octet of these oxygen atom is complete. Now fifth step is complete the center atom's octet complete the center atom's octet by making single dot. Okay, so we are going to, so what will happen from here, the electron pair will shift to this nitrogen atom. Okay, it will shift to this nitrogen atom. So we will be getting here, nitrogen is there in the middle, oxygen, oxygen, oxygen. Okay, so 1 2 3, and electron have shifted here. So this 1 2 3 4, 1 2 3 4 5 6, 1 2 3 4 5 6. So now for nitrogen, 1 2 3 4 5 6 7 8. So you look at each atom in this molecule. Every atom's octet is complete, and in the last you have to put the sign which is -1. Now you want to count, you count the number of electrons would be 24. Okay, 6 over here, 6 and 6, 12, 12, 13, 14, 15, 16, 16, 17, 18, 19, 20, 21, 22 are there. We want to put 24 electrons. So it means 2 electrons are present here as lone pair of electrons. Okay, so the structure of nitrate ion, the Lewis structure of nitrate ion is